Hey guys, today's question is bitwise XOR of all pairings. In this question, we are given with two arrays nums1 and nums2, zero indexed arrays, consisting of non-negative integers, and there exists an array nums3 which is not given of course, which contains the bitwise XOR of all pairings of integers between nums1 and nums2. Okay, so what this means is, like for this example, nums1 is given as 213 and nums2 is 10250. So the nums3 which is not given here will be 2 XOR 10 XOR 2 XOR 2, XOR 2 XOR 5, XOR 2 XOR 0, XOR with 1 XOR 2, 1 XOR 10, 1 XOR 5, 1 XOR 0. So all these elements will be XORed with these elements, and afterward that, uh, which contains the XOR of all pairings, return the bitwise XOR of all integers in nums3. We have to again take the bitwise XOR of all integers in nums3. So whatever the resultant array is, we have to take the XOR of that array. Okay, so for this example, this is given for this 213, 2 XOR 10 is 8, 2 XOR 2 is 0, 2 XOR 5 is 7, and 2 XOR 0 is 2, and so on. 1 XOR 10 is 2, here given 11. So this is the third array nums3, and we will take the XOR of this array, and the XOR of this array will be 13, and this is our answer. Okay, so now let's see another example to understand the approach. So what we can see, we will take the XOR of every element with the every other element for this array. So our final XOR will look like something like 1 XOR 2 XOR 3 XOR 5 XOR 1 XOR 2. So what will be our final array will be 1 XOR 3 XOR 1 XOR 4 XOR 1 XOR 5. Okay, because we have to take the XOR of the final array also. So we can see this one will be taken XOR 3 times. Okay, and this 2 will be taken XORed 3 times because there are 3 elements in the right side. Also for these elements in the nums2 3 4 5, this 3 will be taken XORed 2 times. Okay, once with 1, once with 2. Now this 4 will be taken XOR 2 times, and this 5 will be taken XOR 2 times. Now let's say if there was more than 4 elements here, more than 2 elements. So let's say there were 4 elements. So this 3 from this side have to be XORed with these 4 elements. Okay. Now what we know is XOR property. If the element is XORed with the same element, it will return in 0. Okay. So for example, 3 XOR 3 will be 0. Okay. And also 3 XOR 3 XOR 3 XOR 3 will again be 0 because it is in the even counts. Okay, so this will cancel out 0, and this will cancel out as 0, and 0 XOR 0 will be again 0. Okay, so what we can see is, if we are choosing any element, like for example this 3 in here, if there are even number of elements in the left side, that means we don't have to take XOR of this value because it will result in 0 of course. Also for this 4 it will return in 0, and this 5 it will also return in 0 after accumulating all XORs. Okay, after taking the XOR of nums3. But for these elements 1 2 3 4 5 in the left side, we can see we will take the XOR of 1 3 times because we will pair one this with this 3, with this 4, and with this 5. Okay, so if this value is odd, okay, if there are three threes, let's say here, so these two threes will be cancelled out as 0, and 0 XOR 3 will be 3. So what we conclude, if there are odd number of elements in the right side, okay, then we have to take this element as XOR but only once. Okay, and if there are even number in the right side, then we don't have to take the XOR because it will cancel out. Same for the nums2 array. If the number of elements in the nums1 are even, then we don't have to take the XOR. And if the number of elements in the nums1 is odd, sorry, let's say there were 3 elements only, then we will take the XOR because this 3 will be XOR 3 times, and 2 times it will cancel out, but for the third time it will give 3. Okay, also you can verify it by taking any small example. For example, if we take 1 XOR 2, this is the nums1 array, and let's say nums2 equals to 3. Okay, so you can see this is odd, this is even. So the what will be the final array is, you can say nums3 will be, this one will be XORed with this 3, so 1 XOR 3, and also this 2 will be XOR with this 3. Okay, so XOR, because we have to take the final XOR also, 2 XOR 3. Now you can see for this 3 we have two threes here because there are two elements in the left side. So these threes will cancel out, okay. But for this 1 and 2, there were only odd number of elements in the right side, so they didn't cancel it out, okay. So these two threes will cancel out. 3 or 3 is 0. Now 1 or 2 will be our answer, okay. That's it. Okay, now let's code. Before coding, we will see this example also. So for this 213 and 10250, you can see the number of elements in the right nums2 are even, okay. So we don't have to take the XOR of nums1, okay. We will simply take the XOR of nums2. So 10250 and XOR of 10250 will be 13. You can verify it. Now let's code for this. So initially, let's take the final XOR as 0. And now if the size of nums2 is odd, then we will take the XOR of nums1 elements, and if the nums1 is odd, then we will take the XOR of nums2 elements, okay. So first, let's say if nums2 is odd, so size of nums2 is odd, that means we have to take the XOR of every element of nums1. So for auto and x in nums1, simply update the XOR as XOR with the current value. So XOR equals to x. Same thing for the nums2 array. So we will first check the size of the nums1 array. If that is odd, okay, not equals to 0, then we will take XOR of with all the nums1 elements. Okay, here should be nums1 and we will iterate it nums2, okay. So if the size of nums1 is odd, then we will take XOR of all elements of nums2, and if size of nums2 is odd, then we will take the XOR of all elements of nums1. Finally, we can return the final answer, which is the XOR, okay. Now let's try to run this. Okay, let's submit this. So the code is accepted. Thank you for watching.